Hey guys, welcome back. We are with the topic of acid, bases, and salts, and I have told you first of all that what is the definition of an acid, types of acids, depending upon its ability to release hydrogen ions, and then we have discussed some different types of the acids regarding their ability, and that is called fully ionized and partially ionized, weaker, stronger acids depending upon the presence of COOH group, which is called as carboxylic group, that if it is present or if it is not present, inorganic or organic acid. I have told you that inorganic acids are also called as mineral acids, but inorganic acids is a better name. Organic acids are also called as carboxylic acids. Both names should be in your mind, and there must be a COOH group as a part of their structure. Afterwards, we have discussed the categorization of acids depending upon their ability to release hydrogen ions. How many hydrogen ions they can release per molecule? One, then it is called as monoatomic. Two, monobasic. Two, if it is two, then it is called as dibasic, and if it is three, then it is called as tribasic. Names of these are not written here, so I would like to write down the names of these as well. It is called as dibasic or it is called as diprotic. Okay. So remember this thing that it is hydrogen ion which is responsible for all the chemical reactions of an acid. Tribasic or triprotic. One more thing which you should know, and I have already told it, but I would like to inform it again. For example, let's discuss hydrogen. Okay, we can say this thing that hydrogen has an atomic number of 1 and mass number of 1 as well. So we can say this thing that if its electron number is 1, its atomic number is 1, its proton number is 1, etc., etc. So we can say that how many neutrons are there. So it is 1 minus 1 is equal to 0. So when it is going to lose one electron, what it will be? It will become this. So that is called a proton as well. So hydrogen ion is called a proton as well. Why it is so? Because it is left with one proton only after loss of that one electron. Okay. So this is how it is happening in case of hydrogen ion, or it is called as proton as well. And I have told you that as far as an acid is not giving hydrogen ions, its acidic properties cannot be depicted. One more thing, that if an acid is with water, then it can show its acidic properties. Okay, if without water, if it is 100% pure acid, it is not going to convert itself into its ions. Okay, so to convert itself into its ions in the solution, it will release its hydrogen ions, which will be then responsible for the acidic properties of that acid. So there must be smaller amount of water or a larger amount of water. That depends upon the concentration, solution, the dilution of the solution which we want to make. That's another question, but right now I'm letting you know that if there will be no water, acid cannot release its hydrogen ions, hence acid cannot depict its acidic properties. So acid plus water, it will be possible for acid to show its acidic properties. Okay, guys, now I am taking you to the next point, and that is related to the reactions of acids with different types of the substances. Okay, let's see. Okay, so for example, we are saying that this is the acid in the center, and it is the product with ammonia, and it is a product with metal oxide and metal oxide. For example, this is with metal hydroxide, and this is with metal carbonate, and this is with metal only. Okay, I would like to make it smaller. Okay. All right. So we can say that we are going to mark it with black lines so that we may have a clear idea, so that we may be able to differentiate. Okay. All right. So whenever any acid is reacting with any metal, okay, it is not any metal. There are certain metals which are not reacting with acid. Why it is so? Because of their very poor reactivity. For example, copper, gold, silver, and platinum are not reacting in with an acid, with the dilute acid specifically. Why it is so? Because dilute acid has lesser concentration of hydrogen ions there. So we can say this thing that lesser hydrogen ion concentration, so acid strength is also lesser, we may say. And you can say that metal is also weaker. I mean to say that metal is not that reactive, hence the reaction is not possible, reaction is not happening. So we have to convert that metal into metal oxide or metal carbonate or metal hydroxide to react with that acid, okay? Or we have to heat the solution so that the reaction can be forced, okay? But I have listed those metals which are not reacting with acids normally. So whenever an acid is reacting with a metal, it is producing metal salt plus hydrogen gas. Hydrogen is a gas which is popping in the flame, okay? And then there is a metal oxide reaction with an acid. As a result of that, it is producing metal salt plus water as well, okay? And there is a third category, and that is with ammonia. For example, ammonia is a gas which we have already discussed. It is a gas with a pungent smell. Pungent smell is a smell which is causing some irritation, or it is pinching, you may say, okay? Pungent smell, and it has a pH value approximately near 10. So you may find such type of a question whenever examiner is saying that pungent smell gas is evolved and has a pH of 10, etc., or has turned red litmus paper blue, then it will be ammonia, okay? And ammonia test and identification test, we are done with this in the previous chapter. So whenever an ammonia gas is reacting with an acid, as a result the product is ammonium salt only, okay? We are going to solve some equations as well. And number four is metal carbonate. So whenever any acid is reacting with metal carbonate, it is producing metal salt plus water plus carbon dioxide, okay? So this is how it is produced. Carbon dioxide is a gas which is turning lime water milky, and it is always produced whenever a metal carbonate is reacting with an acid. Then the last category is metal hydroxide. Metal hydroxide is also producing same type of the results as that of metal oxide, but the balancing of the chemical equation will be different in case of metal oxide and metal hydroxide. So this is the categorization you need to keep in your mind. So here it is metal salt along with water, okay? So this is how it is the reaction of different type of the substances with an acid, okay? Now I'm giving you certain examples. For example, let's react potassium, sodium, calcium, zinc, you may take magnesium as well, okay? And we are going to react it with different types of the acid. So here we are reacting with HNO3 and sodium. Here we are reacting HCl, and here we can react again H2SO4. Here we can react CH3COOH even, which is a weaker acid. As organic acids are weaker acids, they have lesser ability to release hydrogen ions. This I would like to write here very clearly. Organic acids, organic acids are weaker acids have lesser ability to release hydrogen ions in water, okay? So this is how organic acids are weaker as compared to, definitely as compared to inorganic acids, okay? So here I'm writing the products. It will be K2SO4 along with hydrogen gas, as the equation is not balanced. So we are going to write this, and this will be NaNO3. One should know this thing that I have repeated these words so many times before as well, that all the elements of group number 7, oxygen, nitrogen, and hydrogen, are naturally diatomic. So hydrogen will be H2 always. So please be careful about that. It is automatically balanced ZnSO4 plus H2, and this is the CH3COO and the whole thing twice Mg with H2. Okay, so this will be 2. Okay, guys, before moving ahead, I would like to inform you that there are how many hydrogens here? 3 hydrogens here and 1 here. So total are 4. but the only releasable hydrogen, the only hydrogen which will be responsible for all the chemical reaction of this whole acid is only this. Okay, so if there are 10 hydrogens or 5 hydrogens, that is not making any difference. This is the only hydrogen which is responsible for all the chemical reactions of that acid. Okay, so you can see this thing that after loss of this hydrogen, the total charge on this partner will be -1. When it will be -1, it will come for 2 times to compensate the charge of magnesium. One should keep this thing in your in the mind that magnesium is a part of group number 2, so it will have a charge of +2. To cancel +2 charge of magnesium, this thingy has to come for how many times? For 2 times. So this is how we are going to write the balanced chemical equation of the metals with acids. Okay, before completing today's lecture, I would like to inform you that in the next class, I will tell you, inshallah, about the ionization equations of acids. I am writing here the heading for the next class: ionization equations for acids. So these equations will tell you that how we can decide that how many hydrogen ions are getting released by each of the acid. Okay, all the best to all of you. See you in the next class. Take care.